we have two inequalities. Sometimes it's in slope-intercept form, sometimes we given us in standard form, just like this. And then it's just up to you as far as how you want to graph them. Now, again, I'm going to stay away from graph paper. We're going to try and scale this on our own. So you just go one at a time. If you've got two colored pens or two colored pencils or anything like that, this is a good, or pen and a pencil, this is a great section to use multiple colors, because we're going to use, we'll probably have 2, sometimes 3, even 4 inequalities within one setup. And we have to shade. The way we shade is just going to be ever so slightly different than what we did before. Before, when we shaded our inequalities, remember how we just kind of drew over stuff, and a lot of you guys know you build in it all the time. Now we're going to use directional arrows. It's a little bit cleaner, okay? So with this first one, we have 3x minus y is less than or equal to 2. 2x plus y is less than or equal to 2. So cover and solve. What's your x-intercept for the top equation? 2/3, okay? So x-intercept is 2/3. I'm going to say 1 is here, so I'll put 2/3 here. I'm going to label it 2/3, comma 0. Okay. What's your y-intercept for that one? -2. Remember, just cover it and solve. So as you're spacing it, notice how you marked out 1 about that far. I marked it out same amount on the other side, and I have a y-intercept then at 0, -2. When I connect those two, will it be a solid or a dotted line? It's solid. Why is it solid? Good. So we connect them through. Oops. We get something like that. Now what do we have to do? Okay. Did it go through the origin? No. No. So 0, 0 is a really good test point, isn't it? What's 0 minus 0? Is that smaller than 2? Yes. Okay. So here's what I want us to start to do for our shading. We know it's going to shade towards the origin. I'm just going to draw some arrows. I'm just going to draw a couple of arrows, as opposed to shading over stuff, because we're going to start to create what's called a feasibility region. What that means is that in that area, it could happen. It's possible. Go to the second equation. Second equation is 2x plus y is less than or equal to 2. Cover and solve. X-intercept at, y-intercept at, x-intercept at 1, y-intercept at 2. Solid or dotted? Again, y. Okay. So far, has this been any other different than the other stuff we did earlier last week or so? I'm sorry, chapter 2 stuff. Any different? No. Yeah. Did that go through the origin? No. Okay, so what's 0 plus 0? Is 0 smaller than 2? Yes. Okay, so I have to shade towards the origin again. So now this feasibility region is where those two arrows merge. Do you see that? That's why I use arrows. That's why I use the arrows, because it's pointing you in the direction of where something's going to occur. It's a little bit cleaner than shading over stuff. Okay? Now, one other thing I want us to take into consideration here is, do those two lines intersect? Yes. Okay, how do we figure out where? We what? You said it. Oh, I thought it was. Exactly, you solved the system of equations. Now, these are inequalities, but when I solve the system, if I want to figure out where those two intersect, I treat it just like I would an equation. Does that make sense? So here, if I wanted to figure out where these two equations intersect, what am I going to do right away between those two equations? Very good. Y. Everybody hear that? Just add the two equations together. What I want us to get in the habit of doing with these things is to, once we kind of graph them, sometimes your lines are going to intersect. You're going to be able to see that with your sketches. I want us to get in the habit of figuring out where they intersect. Some of them might be pseudo-clean, some of them might be kind of crappy, but in the long run, this is just practice for next week. Okay, it's just a little bit of practice for next week. By continually solving systems, which is what we've been doing for the past couple of days. Combining these things here, what we get, 5x is 4, so x is 4/5. Are you okay with that? All right. Now it's just a matter of which equation do you want to substitute that back into. I would do the second one as well because it's got a positive value of y. So if I substitute that back into the second equation, I get 2 times 4/5 plus y is 2. Well, 2 times 4/5 would be 8/5, and then I have to subtract that over. Are we okay with that? Now, if I subtract that over, I'm going to get y is going to equal, how do I convert a 2 into something with fifths? Very good. It's 10/5. So our y value would be at 2/5. So your intersection then, 4/5, 2/5. Sorry about mine. Okay. Wow. Same basic principle of what you were doing yesterday and the day before, but we're just adding that one extra step of shading. Okay. Not bad? I don't know. This one's easy. This one. Guys. Pretty please. If you want, absolutely. If you want to switch the forms around, if you want to do that, go for it. It's no big deal. Or even if it's kind of funky, if you want to try and practice your scaling, it still works. Okay? What I mean by practicing your scaling is how you mark off your lines. All right? Again, try to stay away from using graph paper for right now so you get the idea of how to draw these by hand. Also, paper's cheap. You can make them bigger so you can see them better. It's okay. All right? So, first inequality, what are your x and y intercepts? Sir? Okay. So you have, is it positive or negatives? So, we know that our x-intercept was at 3, our y-intercept that would have been at -1.5, 3/2. So 1.5-ish. Label 3, 0, 0, -3/2. When I connect those two, is it solid or dotted? And why? Very good. Hey, yeah, I wonder what our good old-fashioned test points are going to be. Probably right. Could I use 10 and 10 if I wanted to? But I didn't make sure it's not on that line, though. Let's use 0, 0, because it's pretty easy. What is 0 minus 0? 0. I'm so proud of you guys for not using your calculator.
Why are you looking at me?
Because you probably wanted to use your calculator. I kid. Hey, you're telling her to run away. I'm figuring I might as well.
I'm just trying to.
So was I.
You just got.
Oh, I did. I kid. Then do the same thing with the next one. In the next one, if I wanted to mark it off the way that it's sitting in slope-intercept form, I've already have some stuff kind of scaled. I could kind of fudge it enough to make it work. Okay. So if I do it that way, let me choose just a little easier to see it, right? I know it's going to go at -4 up 3 over 1. Up 3 over 1. And I basically get something like that. Let's see. Solid or dotted between those two? Dotted. did that go through the origin? Is 0 bigger than -4? Yes. So I can shade again towards the origin. So you have this feasibility region within here. The only thing left to do is to figure out where those two intersect. Okay? Now, I know it looks like it landed on that line and it landed somewhere, but I got to figure out exactly where it is. So in this case, see how this is y is, if you go back to when you're solving the system, disregard the fact that it says any inequality. Treat it as an equal sign. One of the methods that we really didn't use yet was substitution. You guys vaguely remember that? So this is the same thing saying, well, y is 3x minus 4, so I can take this value y and throw it into there. So you have x minus 2, quantity of 3x minus 4 is 3. And again, this is where most of you guys are going to go, well, why are all those equal signs there? Remember, when you're trying to figure out where something intercepts, that's where the two lines are equal, so they have to be equal. Right? That's what we're doing. So I distribute out, solve, we have what? X minus 6x plus 8. What was that? -5x. So x is at 1. I like it when it's easy like that. And then what's your y value? -1. Very good. So my scaling was correct. The intercept at 1. Right. Check this out. I did. I didn't have to distribute this x because that's out in front of it. Because I'm substituting here, it's x minus 2 times y. So I'm substituting the y value here. This is, if this was like a 4, you would have, but the fact that it's just a singular one, that's probably why you thought that. Okay. Good question. Good question. All right. Yes. Well, if I get 1 for x, because I have x, this becomes -5. Move the 8 over, you get -5. -5 divided by -5 would be 1. If I throw 1 back into here, 3 times 1 minus 4 is -1. Gotcha. There you go. And that's what it looks like. Some of them are going to be clean, some of them will be kind of ugly, some of them will be fun, some of them won't. Don't be sad. It's going to be all right. Oh no! Skill chip! Yeah. That's not. Yeah. No. Hold on a second. Hold on. Where is x greater than or equal to 0? What? All right. Let's go. Sorry, rephrase this. What are the? Do you guys remember the quadrants? Yeah. 1, 2, 3, 4. What quadrants, or quadrants, is x positive? Because that's basically what this is saying. 1 and 4. Okay? X is positive, 1 and 4. Okay? Where's y positive? 1 and 2. Now, immediately, where do those two overlap? Quadrant 1. Whenever you see this is going to become kind of a big thing. That means it is automatically a quadrant 1 problem. Because those first two restrictions force you here, in that upper right-hand corner. That's all you're going to be, no matter what, that's the bare minimum where the feasibility is going to occur. So when you see that, or if you see just x is greater than 0, greater than or equal to 0, and you don't have anything for y, you know it's got to be the first and fourth quadrant, okay? It's those ideas of how can you bound your region without having to draw the giant thing. So as soon as I know that I've got a first quadrant problem, I don't draw all 4 quadrants. I just draw one. Because I know it's a first quadrant problem. All my x values are greater than or equal to 0. All my y values are greater than or equal to 0. I draw 2 arrows on the corners, and I know it's going to be in there somewhere. All right? From there, I just go to the next bit. What are your x and y intercepts for the for the third inequality? 6 and 8. So x is at 6, we'll say here-ish. And 8 be about here-ish. When I connect those two, is it solid or knotted? Solid. Did that go through the origin? No. What's 0 plus 0? 0 is 0 smaller than 24. Which means you're shading towards the origin again. So here, you're bounded by 0, 8, 6, 0, and what's your bottom boundary? The origin, which is at 0, 0. You created a boundary, a bounded region. Okay? Within the 3, you can get 3 points. And actually, what you did here is you found the solution for all 3 of these to make it work. Yes, ma'am. Cover and solve. What's your x-intercept? Remember we cover up and solve? Cover up and solve. Okay.
What would happen if like x is less than 0, y is?
Then you be the other way. Yeah. If it's less than or equal to 0. If it's, excuse me, rephrase that. If you're saying that x is less than or equal to 0, that's going this way. Y is less than or equal to 0, it's going this way. So it would be in quadrant 3. That's where they're both, basically what you're saying is where are they both negative. So when here you're both positive, here you're negative, positive, here we're negative, negative, here we're positive and negative. Do you remember when we were talking about h's and k's? Remember how they corresponded to x's and y's? So isn't this x is positive, y is positive, x is negative, y is negative, x is negative, y is negative, positive, and negative? Do you vaguely remember I said, hey, tuck away this little bit of thoughts, something about trigonometry? What comes first in the alphabet, sine or cosine? Cosine, what comes first in the alphabet, x or y? It's just, what it has to do with what you're doing now is because this relates to the exact same thing when we get to this. You got a calculator out, right? Hit the button that says mode. Switch it to degree. All you have to do is move the arrow over and hit enter until it highlights it. I'm pretty sure. I know it is crazy, but I'm a crazy guy. Shit. I know, you're welcome. Hey, what's cosine of 30? Hit the button that says cosine and hit 30.
0.8660.
Okay. So it's positive. 30 degrees is in the first quadrant, and this is 0 to 90. Hey, what's greater than 90 but less than 180? Maybe 120. What's cosine of 120? All right. Try negative 200, or try 200 degrees. Cosine of 200. Does that get you this third quadrant? It's negative. All right. Try 300 degrees.
What? It's 200.
And it's positive, isn't it?
Yeah. Oh.
So what grabs the firm goal? But anyway, starts at a positive, goes to 0, goes to negative, goes to positive, and goes back. That's everything.
Is it 0 and 90?
X is always positive.
It is 0 and 90. Then it's gotta be 0, no, it would be 0 and 270, right? But it wouldn't be 0 and 90.
Okay. Why is cosine? Let me ask you this. You're right. Watch what happens. If you're there, what's your ordered pair?
0 and then whatever the y.
If you're here, what's your ordered pair?
0 and whatever the y.
What comes first in the alphabet? Sine or cosine?
Also, it's 0 and whatever the sign is.
You got it.
Alright, I passed the class?
Sure. See you tomorrow.
I'll see you.
No, seriously, what you just figured out is pretty sweet, because the relationship to what are called quadrantals, you've got 90, or we'll call pi over 2, pi, 3 pi over 2, and 2 pi. As you rotate yourself around, cosine goes to 0, because x becomes 0. Cosine goes to 1, goes to negative 1, 0, positive 1. Whereas sine starts at 1, goes to, starts at 0, 1, 0, negative 1. And that's how all that works. That's pretty cool. They pick that up. Yeah. Don't worry. We got plenty of time. All right. We okay? I don't do too much because this stuff's pretty straight. Tonight, let's see here. 3-3, let me pull this up here real quick. Skill check. Yeah. Let's try, let's see. Thanks. We're all cool. Do those 6. It's, I don't remember the page number, but it's in section, page 160, thank you. Yeah, I will. It's section 3.3. All right. For right now, try, if you have intersections, try and find some of your intersections. I know that we didn't get a chance to talk about the 4 ones. They can get a little muddy. But I guess for right now, if we're okay just doing shaded, we can just shade. You don't have to solve those out tonight because we ran out of time to use the larger ones. We'll talk about how, just shade, okay? For tonight, we're just gonna shade. Don't worry about your intercepts. When we get to the larger style problems in there, we'll talk about how to do those later, okay? No big deal. Put it through our arrows. Like I said, if you have different colors, try and use different colors for some of these because it does help to see which ones you're looking at. Yeah,